So we discussed when we apply two equal and opposite deforming forces parallel to the cross-section area of the cylinder, as shown here. If the external force is applied in this direction, then the restoring force is developed exactly opposite to this applied force. This restoring force per unit area is called as tangential stress or shearing stress. Here, the displacement is delta x and the angular displacement is theta. Now the strain is defined. The change here we are representing as delta x. So the relative displacement here, the change is not change in length. Here it is relative displacement. This is denoted as delta x. The relative displacement per original length, it is called as a shearing strain. That can be mathematically calculated as tan theta, where theta is the angular displacement. Theta, when we take it, is very small, then theta is almost equal to tan theta, because tan theta value for smaller values of the theta, tan theta is almost equal to theta. Now we will discuss another stress. You take this example. Here we can consider the example C. In this case also we are applying the force with the hand. We are pressing here. The stress which is acting, the restoring force per unit area which is acting against this is called as same shearing stress. This we know. By seeing this picture we are able to understand. Now in another example here, we are applying, there is a solid sphere. Okay. The solid sphere is placed in the fluid. This is under high pressure and it is compressed uniformly on the all sides. You see the arrows. Uniformly it is being compressed from all sides. Now the force applied by the fluid acts in perpendicular direction at each point of the surface. And this is under hydraulic compression. So because of this compression, there is a decrease in the volume of the fluid. So this decrease in volume is denoted with the delta V. So the internal forces means the restoring force. The restoring forces, they are exactly acting opposite to the applied force. So in this direction, they are trying to restore. So I am drawing the internal forces. These are the internal forces. They are exactly acting opposite to the applied forces. So they are trying to restore the shape. So they are trying to restore the volume. In this case, the restoring forces per unit area we are calling as hydraulic stress. So the restoring force, we are taking the single restoring force we are taking per unit area when we consider this is hydraulic stress. And the strain produced by the hydraulic stress, this is called as volume strain, because there is a change in volume. Here we compressed and similarly we can expand also. In that case also, volume strain is delta V. Delta V can be positive or negative. If we compress, its value is one thing. If we expand, its value is one thing. So the volume strain is defined as change in volume to original volume. So there are no dimensions to it, because volume by volume, there are no dimensions. So we have discussed what is tensile stress and we have discussed what is compressive stress. And we also mentioned these two stresses are coming under the longitudinal stress. We described the strain related to longitudinal stress as longitudinal strain, and we have given the equation as delta L by L, where delta L is the change in length. It might be increasing or decreasing in the case of the stretch or compression. And later we discussed the shearing stress when we applying the force parallelly, and the related strain to shearing stress is shearing strain, the relative displacement delta x by L, and later we discussed hydraulic stress. In this hydraulic stress, the volume is increasing or decreasing. The change of the volume per the original volume, the strain related to this hydraulic stress is called as volume strain.